All right, so we've got a cat running at 5 meters per second and accelerates at 1 meter per second squared while it runs 10 meters, and we want to know how fast it's going at the end of that. All right, so can somebody start by giving me one or two of the givens that we have here?
How fast it's going?
Yeah, so how fast it's going, what's that, what given should I, or what quantity is that?
5 meters per second.
5 meters per second, all right. And what symbol should I use per second? What's the symbol? Who knows?
Velocity.
It's velocity, right? So and it's the initial or final that we're talking about there?
Initial.
Initial, right? So the starting velocity. So that's VXI for 5 meters per second. Okay, what else?
That it accelerates at 1 meter per second squared.
Yeah, so what quantity? What's the symbol that I use for the 1 meter per second squared?
Y.
Not Y. What's the, what says it accelerates at 1 meter per second squared, right? That's the acceleration. So I'll use the AX, right? Our symbol for acceleration, A. And one more given, right?
We got the displacement.
Displacement, thank you, Angel. What's the displacement?
10 meters.
10 meters, good. So delta X, 10 meters. All right, so we've got 3 givens, so we should be good for givens. And what about the unknown? Which one, which symbol, which quantity are we looking for? If it says how fast is it going at the end?
The final velocity.
The final velocity, right? So the X final is my unknown. Okay, so I have VXI, AX, delta X, and VXF. Which of the big 4 kinematics equations am I going to use to solve today's problem? VXI, AX, delta X, VXF. Only one of those equations has those 4 symbols.
Last one.
Yeah, the last one, right? VXI, AX, delta X, and VXF. So we picked the last equation. That's the only one that has those exact 4 symbols in it. Final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. So step 4 is to rearrange our equation, right? Get our unknown all by itself on one side. We're looking for VX final, and that is all by itself on one side. Well, it's VXF squared, so we'll have to take the square root at the end, but we don't need to do any rearranging. We can just start with, go ahead and plug our numbers in. So our VXI was 5 meters per second, and it's not 0 this time, so make sure we don't forget that part of it. So we have to do 5 meters per second and square that, plus 2 times our acceleration, which is 1 meter per second squared, times our displacement, which is 10 meters. All right, so I can plug that into the calculator and get my answer. Let's see, I've got 5 squared plus 2 times 1 times 10. Should be 45. Yeah, so that means my final velocity squared equals 45. And it looks like the unit I'm going to end up with is meters squared per second squared here, right? If I do meter times meter, it's meters squared over second squared. And meters per second, if I square that, it's meters squared over second squared. But this isn't my final answer, right? This is the square of the final velocity. So there's one last thing I need to do to get the final velocity, and what would that be? If I have the square of the final velocity, what's the last step I need to take just to find the final velocity? How do I undo the square?
We need to take the square root of
Yeah,
45.
that's right. I heard a couple people say it there. Yeah, that's right. The square root, right? We take the square root of 45. Well, and if I take the square root of 45 on the calculator, 6.7. So what I end up with is the final velocity equals 6.7. And the unit now, since I've taken the square root, is just meters over seconds. Right, and meters per second, that's the unit for velocity, so that makes sense. It looks like we did it right there. And if we started at 5 meters per second and we only accelerated a pretty small amount, ending up at 6.7 meters per second seems pretty reasonable.